Hi, in this lesson we are going to review more ways of reducing radicals. The first thing I want to do is remind you of how to rewrite a rational exponent as a radical. So as you look at this, the denominator here of this rational exponent is your index of your radical, and the numerator is the exponent that goes on the radicand. So I would rewrite this as the fourth root, that's the index, of the quantity 10x to the fifth power. It can also be written as the fourth root of 10x quantity to the fifth power. Either way is correct. I'd like you to try all of these problems, and when you're done, I will explain the answers. Okay, so here are the answers, and you'll notice 5 is the index, 7 is the exponent. Here, 2 is the index, that's a square root. We don't write the 2, but it's still there. 3 is the exponent. Over here, 2, index, square root, 3, exponent. I could have also written these on the inside as well. Here, 4 is the index, there it is. Obviously, this is not the right answer because the exponent should be 1. So this is the fourth root of 10v. The next thing I want to do is simplify a radical when my denominator is a binomial. So the way we do this is we multiply by what we call the conjugate. So if I have a plus b, the conjugate of that is a minus b. And the reason this works, and the idea is that I do not want to have a radical in the denominator. So if I were to multiply out a binomial with its conjugate, the middle term cancels out. So this would give me a squared minus ab plus ab minus b squared. So you just end up with the first term squared minus the last term squared. Well, if I square square root of 6, that's going to get rid of my radical, and I won't have any middle terms there. So we're going to multiply by the conjugate. That would be negative 3 plus the square root of 6 over negative 3 plus the square root of 6. That is allowed because all I'm doing is multiplying by a form of 1. So let's see, let's move this negative up to the numerator. So this becomes 21 minus 7 square root of 6 over negative 3 squared is 9, and square root of 6 times square root of 6 is 6. So that would be minus 6. So I end up with 21 minus 7 square root of 6 over 9 minus 6, which is 3. Now, if each of these values were divisible by 3, I would then reduce it. But since that's not the case here, this is my final answer. Next, I'd like you to give these two problems a try, and then I'll talk about the answers. Okay, you can see here, again, we're multiplying by the conjugate. So 5 plus 8 root 3, so instead I do 5 minus 8 root 3 on the top and the bottom. Once that happens, I distribute this 5 to the inside, and I get 25 minus 40 square root of 3. And then the bottom, 5 squared, 25. My middle terms cancel out. 8 square root of 3 times 8 square root of 3 is 8 times 8, 64 times 3. Simplifying, I get 25 minus 40 square root of 3 over negative 167. That's really not a really good look when I have a negative in the denominator like that. So I moved the negative to the numerator, took the opposite of my numerator, that's negative 25, plus 40 square root of 3 over 167. So answer B. Number 6, I multiplied by the conjugate, which was 9 plus the square root of 10. The 3 got distributed here. Then in the denominator, I get 81 minus 10. Here's my answer. The answer was A. Next, I'd like to simplify a radical with a higher order index in the denominator. So it's really important that you realize something. This is the fourth root of 3 squared down there. So the question I ask is how many more 3's do I need to get it out of the radical? And the answer to that question is I need 2 more. So that becomes 3 fourth root of 9 over 3. So that would be my simplified version. I want to show you one more example because this is a common problem. Let's see. Let's make this 3 over the square. Let's make it the third root of 4. So I want to reduce that. I've got to rationalize my denominator. We need to recognize that my denominator is the cube root of 2 squared. So in order to remove that radical, I need 1 more 2 because I need a set of 3 of these. So I would multiply by the cube root of 2 over the cube root of 2. Notice I am not multiplying by the cube root of 4 over the cube root of 4. That wouldn't take care of eliminating my radical. I need sets of 3 in order to do that. So now this would give me 3 times the cube root of 2 over 2. And that would be the simplified version there. I'd like you to give these problems a try. After you're done, I will explain the answers. Here are my answers. I want you to notice that I rewrote 25 as 5 squared so that I could more easily decide what needed to be multiplied by on top and the bottom. I need sets of 3. So this got multiplied by the cube root of 5 over the cube root of 5. That gave me 5 cube root of 5 over 5. I have 3 5s. 1 comes out. The 5's cancel. I end up with the cube root of 5. So answer B. For number 8, I had to multiply. This was 7 over the cube root of 3. I had to multiply by the cube root of 3 squared. I need 3 3's to get that out, get rid of the radical. So this ended up being 7 cube root of 9 over 3. Answer A. Now, we should be able to do the same with variables. In this case, we're going to assume all variables are positive so that we don't need to worry about absolute values. So I have 2 n's. I need to multiply by the cube root of n because I need 3 of them. So this becomes 3 cube root of n over n. That is my answer. I'd like you to give these 2 problems a try, and when you're done, I'll discuss the answers. So here are my answers. So the first one, I had 2 v's and I need 3 of them. So I multiplied by the cube root of v over the cube root of v, and this was my result, answer B. For number 10, I had 1, 2, I need 4 of them, so I needed 3 more. And I have 1 m, I need 4 of them, so I need 3 more. So I rationalized. I got 2 times the 4th root of 8m cubed all over 2m. So that concludes our review for today. There's a practice worksheet out online for you. Have a nice day.